Let's do an example of finding the TMB factors. Here we have our curve in the space, and notice that we have the 3 sine t and 3 cosine t here in the xy component. So if you look at the xy plane, you see a circle with radius 3. But in the z component, we have 4t, which is increasing, and you will just get like an upward spiral like this, and that's called helix. Alright, let's find the unit tangent factor first. So that's capital T, which is defined to be the derivative of r, and we just have to divide it by its magnitude. Alright, so to find the derivative, we just have to differentiate this, and that. So first one, we'll get 3 cosine t, and then the derivative of this is negative sine, so we have negative 3 sine t, and then we have the j, and the derivative of 4t is just 4, so we have 4k. Yeah, and then we just have to divide it by the magnitude of this, so we just have to take the square root, and we square each component, and then we just have to add them up. So 3 cosine t, and then square that, and then we add negative 3 sine t square, and then don't forget the 4. Square that. Alright, this is just this is just 9 cosine square, and this is also 9 sine square. So we can factor out the 9, and then we will have the sine square plus cosine square. So in fact, you can see that this and that will just give us 9. And this right here is of course 16. So square root of 25 is just 5. So it's pretty much this, divided by 5. And alright, and then for this right here, of course, we can just 4. And now, this right here is just 9 cosine square t, and this is also going to give us 9, but we have sine square t. We can factor out the 9, and then we get cosine squared plus sine squared, which is our girlfriend, 1. So this right here is just 9. And then plus 16. So we have square root of 25, so the denominator is just a 5. So of course, we can just divide each component by 5 and we'll be done. So t equals, let's put 3 over 5, and then we have cosine t, and that's with the I. And then next we have negative 3 over 5, so I'll put down plus negative 3 over 5 sine t, and then j, and then lastly 4 over 5, so plus 4 over 5 k. So here we have our unit tangent factor. Next, we are going to find the unit normal, so that's capital N, and that is going to be dt over its magnitude. So we look at this and take the derivative, and then we'll get this right here will be negative sine, so it's negative 3 over 5 sine t I, and then take the derivative, we get negative 3 over 5 cosine t j, and the derivative this is 0. I'll still put on 0 and then k like this, and then divide it by its magnitude. So take the square root, square each component, so this is negative 3 over 5 sine t square plus negative 3 over 5 cosine t, and then square, and then plus 0 square. Of course, it doesn't matter. Now this right here is just going to be 9 over 25, and then we have the sine square t, and this right here is also going to give us 9 over 25 with cosine square t. Usual deal, factor out the constant, and then we'll just have sine squared plus cosine squared, which is just 1. So it's just square root of 9 over 25. So the bottom is going to be 3 over 5. Then we will just have to divide. Now check this out though. Take this divided by that, they cancel, so it's very nice. So we have negative sine t, I, and then this and that also cancel. So we have plus, I'll put on plus negative cosine t, j, and plus 0k, which doesn't matter. Yeah, so we have the t and also the n. Now we are going to find our unit binormal factor. B is divided to be t cross n. And let's set up our matrix. So for the I component, from t we have 3/5 cosine t, and then we have negative sine t from the n. Next, for the j component, we have this and that, so negative 3/5 sine t, and then negative cosine t. And then for the k component, we have 4/5, and this right here is 0. Now we are going to just do the cofactor expansion. It's not so bad, especially you have a 0. So I'm going to do the cofactor expansion across the first row. And remember, we have the positive, negative, and positive. So take the I, delete this, delete that. We will have to find the determinant of this. So we do this times that, which is 0. And then we will have to minus this times that, which is 4/5. And then times cosine t, but that's a negative. Negative times this negative makes that positive. So that's the first component. Next, for the j component, we will have to subtract. So subtract, and then we have the j. So delete this, delete that. We will have to do this, that. Take this times this, which is 0, and then we will have to subtract this times that, which is 4/5, times negative, so that will make this positive, and then we have sine t. And then finally, for the k component, we will just have to add. So delete this, delete that. Take this times this. That's negative, so we have negative cosine times cosine is cosine squared, and we have the 3/5 here. And then cosine squared t, and then subtract this times that. Negative times negative is positive, and then sine times sine squared, and then we have the 3/5. 3/5 sine squared t, and that's the k component. Now, if you look at this, we can factor out a negative 3/5, not so bad. And then we end up with cosine squared t plus, because we factored out a negative right here already. And then here we have the sine squared t. And of course, that's our good friend 1. So all in all, it's just negative 3/5. And that's pretty much all the simplification that we can do. So finally, we will just have 4/5 cosine t times I. And then I will just say minus 4/5 sine t, like this, and then j. And then finally, we have minus 3/5 k. Yep, this right here will do it.